My project was based on this data set that I found on Kaggle for car crashes. Um, and if you guys want to see, this is the entire data set, but then I also split it up into several smaller portions. For example, like just 2021 or like just 2016, for example, just to make this data set a little bit smaller because I'm pretty sure this whole thing is over a million rows long. Um, and if you see the data set, it's pretty detailed. You have things like start time, end time, longitude, latitude. Um, you have which side the car was hit. You have which state, which city. You have things like humidity, pressure, visibility, where the crash occurred, and also whether it was daytime or nighttime. So I created a bunch of graphs using this data set, and this is the program that I used to run all this. Um, should I make a REPL of this afterwards? I can share this at the end. But anyways, so first I graphed all of the weekdays. Now I don't want to like really run the program because I think that would take too long to do, but I did take the graphs in advance so you guys could see. And first thing here is the year. I accidentally put the title wrong, but you can see here there are a lot more data points for 2021 than there are for any other year. Now, this doesn't necessarily mean that there were way more crashes in 2021. It just meant that the data set didn't really have much information for all these other years. And the way I can get the year is using dt.year after converting the dates to pd.toDateTime. So now this is the weekdays, and then as you can see here, 0 is Monday and 6 would be Sunday. And as you can see on the weekdays, there are a lot more crashes compared to the weekends. And this makes a lot of sense because there won't be as many people driving around on the weekends compared to the weekdays because people still have to go to work and stuff like that. Next, I plotted the months, and interestingly, as you can see, the closer to the holiday season you get, more and more crashes pile up. And again, this also makes sense, you know, with stuff like holiday sales and people doing last minute like Christmas shopping or whatever. It's very apparent that there are a lot more crashes in December, and then as soon as you get to January, the crashes go down again. Next, I plotted the hours, and you can see this is from 0 to 23, and this essentially is from 0 to 12. This is like AM, and then 13 to 21 is PM. And again, you can see that normally when people go to drive to work around that time, there's a lot of crashes. And then when people get off work, there are a lot more crashes. And again, you can use the toDateTime to get the hour. Oh, okay. So next, I did a graph on weather conditions. So, well, first thing, I minimized the text in order for you to see some of the weather labels because a few of them are pretty long, like moderately cloudy, stuff like that. And as you can see, things like fair and mostly cloudy, these kinds of things were the most common, which might be surprising because you might think that more crashes would happen during rainy days or snowier days. But this makes a lot more. This still makes a lot of sense because fair or like cloudy days are much more common in the year compared to more extreme weather conditions. Okay, and then I have the crashes graph based on day and nighttime, and then these are just different types of day-night cycles, but they essentially convey the same information. So again, you can use pd.toDateTime to get this information, and then you can see whether the crash has happened during the day or happened during the night. Of course, even though there are a lot more daytime crashes, it is expected simply because more people will be driving around during the day. And next, we have a graph of every state, and these are sorted based. The states are named by their postal names. So you see, instead of California, you have CA here, and as you can see, California, Florida, Texas, these more heavily populated areas, and the ones that get a lot of tourists, these typically have the most crashes. However, I did find out that this is probably not the most accurate graph because a lot of the like central U.S. countries don't have a lot of data points in this data set. And you can kind of see that with this graph, which is crashes divided by state population. And as you can see, some states don't even show up here because there's just not enough data on them. So in my original data set, there aren't actually the population numbers for any of the states. So instead what I did was if I pull up the program here, I use value counts to get the total number of crashes for each state. And then I merged those numbers with another data set, which essentially just gave me all the population numbers. And then finally what I did was I used that information to create a graph, and that's what you see here. So again, California is pretty high, Florida is pretty high, Texas is actually surprisingly low, but again, this data set is not fully complete, which I didn't realize until I got to around here in my project. So my final graph after this map is visibility. And so normal visibility is around 10 miles. And as you can see, there are a lot of there are a lot of crashes that happen around normal visibility, but then again, the visibility is in miles, and I don't think you need 10 miles to see a car coming, and most crashes happen from behind anyways. So it makes sense that most of the crashes happen when you can see perfectly fine. And then finally, I have this map, which plots down every single crash using the longitude and latitude. And I also have these color coded based on the severity to traffic. So the way the dataset organizes these is that red is equal to 4, orange is 3, yellow is 2, and then green is equal to 1. And using those numbers, I can plot them with a specific color. And again, as you can see, most of these like central states don't have many data points on them, so they appear mostly blank. And that's it for my project. Do you guys have any questions?
Yeah, if you can share the code with us, that would be great.
Okay, yeah. I don't have a REPL created just yet, so I'll create a REPL now and then I'll share it when I'm finished with that.
Right, great, thank you.
And what inspired you to do this?
So originally, I wanted to do something on driving under the influence, or like driving while while being intoxicated. I searched a lot online for any data set, and I found a couple about DUI, but they weren't super detailed, which is why I eventually picked the data set that I found. And even then, it wasn't fully perfect.